Hello, in this video I am going to explain how to find rank of matrix by normal form. So first we study what is a normal form for a given matrix. So let A be any given m by n matrix with rank R, then that matrix we can reduce by applying elementary transformations on matrix A to either one of the form IR 0 0 0 or IR 0 or IR 0, where R is rank of the matrix. In short, in the reduced matrix, all the diagonal elements are either 1 or 0 and non-diagonal elements must equal to 0. After that diagonal entry contain first 1 then followed by 0. So here I will explain one example how to find rank of the matrix by normal form. Suppose A is a matrix of order 3 by 3. By reducing this matrix A to the normal form, we have to find the rank. Now first start with the given matrix. So our first step is try to obtain that A11 element as a 1 by applying either row or column transformation. So while applying row or column transformation, remember that so try to avoid fractions. If it is not possible, in that case you have to include that. So here one can think or one can apply the transformation such that C1 divided by 2, because all the elements in the first columns are divisible by 2. If we divide that first column by 2, we get A11 element as a 1. Or one may apply C1 plus C2. So if you apply C1 plus C2, you will get A11 element as a minus 1. So try to obtain this as a plus 1 or minus 1. So here I will apply C1 divided by 2. So this elementary transformation shows that you are changing the first column by that column divided by 2. Then the resultant matrix is given by. So when you are applying column matrix, represent that matrix column wise, only change for the first column. So 2 divided by 2, that is 1, 6 divided by 2, that is 3, 8 divided by 4, 8 divided by 2, that is 4. So remaining matrix as it is. Now first step, we are getting that A11 element as a 1. So after getting A11 as a 1, so next we have to reduce the elements which are below A11, that means 3 and 4, by using row transformation. So we use A11 or first row to reduce these two elements as a 0. So that first row we call as a pivot row. Now see the transformations here. So to reduce this 3 as a 0, you have to change that second row by R2 minus 3R1. At the same time, to reduce this 4 as a 0, you have to apply the transformation R3 minus 4R1. So we consider the transformations one by one. Suppose R2 minus 3R1 first you are applying. So consider a second row, that is a 3 minus 9 and 15, that is a second row. Next consider a 3R1, that means multiply first row by 3, then you will get 3 3 is 1, 3 3 9 with negative sign, 3 5 15, and you have to take subtraction of these two. Then the resultant row is identically 0, because R1 and 3R1, R2 and 3R1 both are identically same. So you have to change that R2 by a new row or new vector containing all elements 0. So you will get a new matrix which is equivalent to A with changing second row. Similarly, we apply that second transformation, that means you have to change that R3 by R3 minus 4R1. In the same manner, consider R3 and 4R1. So this is R3 and 4R1, you have to take the subtraction. Again that resultant is a 0 row. So you will get a new matrix which is equivalent to A with change for third row. So first step, once again I will recall, you are reducing the elements below A11 to 0. So after getting these elements to 0, next you have to reduce the elements which are right side to A2 to these elements to 0 by applying column transformation. In the same manner, you can guess a column transformation to reduce these elements as a 0. Now here, the column transformations are, you have to change that C2 as C2 plus 3C1, and C3 you have to change as a C3 minus 5C1. So by applying these two transformation, you will get a new matrix where all the elements in the leading diagonal are either 1 or 0 and non-diagonal elements are 0. So by the definition of normal form, so here you are getting a new matrix which is equivalent to the given matrix A, which is in the normal form, and that matrix we can denote as I1 stands for unit matrix of order 1, I1 stands for unit matrix of order 1, and all these 0 stands for a 0 matrix. And whatever unit matrix of order R you are getting here, in this case you are getting a unit matrix of order 1, and that is nothing but the rank of A. So hence in this case rank of the matrix A is 1. Now here I want to explain, you are after applying the second step, that means after getting the elements below A11 to 0 and right side to A11 to 0, that same procedure you have to repeat for all non-zero diagonal elements. So for this example, I am getting all remaining diagonal elements as a 0, so rank is A. Otherwise, repeat the same thing, whatever you are applying for A11, that with A22, A33, like that you have to continue, and finally, so the reduced matrix where all the diagonal entries are either 1 or 0 and non-diagonal element 0, and that you have to convert to the form. So rank of A is R. In the same manner, you can try for further examples. Thank you.